I have to tell you Starbucks secret. Starbucks secret. Truth. How many sizes are there? No. This is the secret. I think there's 4. You think there's 5? There's 4 sizes. Great. I'm trying to give you some money saving advice. There are 4 Starbucks sizes, okay? Venti, Grande, Tall, and there's a smaller size called Short. But they don't put it on the menu. But you can still buy it.
But sometimes I think that's what I make on.
It's for anything. I know because I get that size.
But I have those one time short espresso.
No. Short is not for that size. Short, like you could get a short Americano.
Too short?
Yeah, maybe about this big. Actually, yeah, about this size. This is a short. You can get it in Starbucks.
How much?
It's cheaper than a tall.
How much?
I don't know, it's different for each drink. So like, maybe it's 25 cents cheaper for a short Americano. So how much is a tall Americano? €2?
2.5.
2.5 for a tall?
Low one.
How much for a tall?
Middle size.
Middle size. How much for a tall? Maybe 2? Maybe 2. So then a short, 1.9 or something. Then a short would be like 1.7. You know, if you don't have much money, you can get short. That's what I do all the time. Or you could make your own coffee. No? Impossible?
Yes.
Impossible, okay. Right. Physics, mechanics. We are lecture. We did principle of moments, didn't we?
Yes.
Yeah. So we're now on cantilevers. Okay. Okay, got your notes yet? So we're continuing with moments, but we're making it a little bit more difficult. So can you write this down? Grace, if you answer these right, I'll never ask you again. If you answer these right, I'll never ask you these again. Don't tell her, go on.
I know.
Go on, take your time. What is it? Very good. Don't tell her. No, don't look at her.
True.
Oh, very good. Only 3 questions. Whoops. What's this one called?
Start with Q.
No, that's this one. Oh, this one, yeah, what's this one? Quadratic. And what's this one?
Q.
Don't tell her. Don't tell her. What is it? Q?
Q.
Cubic.
Cubic.
And what's this one? Okay, great. I'll ask you tomorrow. If you get these all right, I'll never ask you again. Is my promise.
And
Yeah, never ask you again. Good deal? I'll ask you tomorrow, okay? What are you telling her?
no.
Nothing? Alright, okay. We'll continue. Did you write down the title?
Yes.
Yep, okay. So, you don't need to write this down. I just want you to have a look at the picture. So these are special types of turning force problems because you can see here there are two forces. One force going up, one force going down, and it makes a turn. Like in this picture here as well. One force going to the left, one force going to the right, and it makes the wheel turn. You see that? Now the forces are equal and they're in opposite directions. And also the forces are the same distance from the pivot. From here to here, and from here to here is the same distance. So, I want you to write this part down now. So let's have a look at this. So for example, if you had like the wheel, there's a force here, there's a force here. We'll call this distance, we'll call the total distance D. So this one here, Amanda, is this force clockwise or anti-clockwise, this force here? Anti-clockwise. So that will be D over 2 times F. Why did I say D over 2? Anybody know? Half a circle, yeah. And then this force here, Yemi, this force here, is it clockwise or anti-clockwise? What is it? Nope, it's anti-clockwise, this force. This is anti-clockwise. So both of these forces are anti-clockwise.
Could be both clockwise.
Huh? Oh, they could be both clockwise. So this is the kind of simple formula I want you to get, that when you have two forces which are equal and that they're distance d apart and they're making the wheel rotate, this is the total moment here.
And both of forces are anti-clockwise.
Say again?
Both of forces anti-clockwise?
Yes, they must be the same direction. Got that? Not yet? Okay. Can I go on now? So this type of force, when it's like this, is called a couple. When you have two forces together like this. So a couple is... Oops, we're stuck. Two equal but opposite forces that are distance d apart and cause an object to rotate but not move linearly. The total turning force is Fd. So these forces only make the wheel turn. They don't make the wheel go forward or backwards. They only make it rotate. Got it? Yeah. Yeah, I'll go on. Yeah, okay. So what we're going to have a look at next now is something called Cantilever. So basically, now you don't need to write this definition down if you don't want to, because it's only more of an English definition of the word cantilever. Okay, so a cantilever is a rigid structure. Well, look, simplest thing is there's 3 pictures of a cantilever. So it could be a beam, for example, and it's usually stuck to something vertical, and this is usually sticking out. So anyways, what I really care about is these 3 pictures. So this is a simple cantilever. This one here with this piece of wood holding it up, that's a brace cantilever. And then this one here with a string helping to hold it up, that's also a brace cantilever. This part here is the compressive strut, and this here is the tensile stay. So what I really need is not this definition. I want you to draw this picture, okay, with all the names in it. You're taking pictures. So what the heck are you doing? You got those pictures drawn? Yes. Got it? Yeah. Amanda? Yeah, I can go on? Yeah. Okay, so there are 3 types of cantilevers. Okay, so we're ready to have a look at some questions here. So the first one is just about the turning force, the couple. So I'll just draw what's happening here in the picture. So for example here, there's a woman and she has both hands on the steering wheel, and there's one force going up of 5 newtons, and then there's one force going down with 5 newtons, and I say that this distance here is 0.3 meters. A woman turns the steering wheel by applying a force of 5 newtons up with her left hand and 5 newtons down with her right hand. So I actually have the picture upside down. The steering wheel is 30 centimeters in diameter. What is the couple? Okay, so what's the formula for the couple here? Well, I gave it to you at the start. It's just F times D. So here it will be 5 times 0.3, which would be 1.5 Newton meters.
What is it?
And that's it, that's all. So this is the turning force on the steering wheel, the moment of the steering wheel. Come on, Bahar, write this down. Got it? Yep. Yes. I can go on now? Yeah? Okay. Oops. Okay. So this one here is really like an exam question. So I'll give you a minute actually to write it down because it's important. Because I've seen this one on the exam a few times. So just go and write from here to question 1, and we'll do it bit by bit, okay? And if your English is good, you don't have to write it all down, you can just draw the picture accurately, if your English is good. If you don't know if your English is good, then it's not. I just need you to write until question 1 first. Whoops. And then we'll put the answer beside it. Okay, are we ready for question 1? Yeah. So it's a 40 by 20 sign. And the stay is attached 40 centimeters up the wall. Okay, so if I was to draw this, here's the sign. For your shop. And this here is 40 centimeters. And then this here is 20 centimeters. And then 40, 20, and it's 2 kilograms. So there's going to be a force here going down, going for 2G. And it's attached to the wall. So here's my wall here. And then there's a hinge here. And then there's the stay here. I think I say that this, I said that this is 40 here. So, by the way, you also know, of course, that this is 40 centimeters. There's another force here, which is the tension. So actually, if I kind of draw. So, Amanda, is my picture beautiful enough? No, okay, sorry, I tried my best. Well, I think it's pretty beautiful. No? Okay, so I have a question here about the hinge. So, if you forgot the word hinge, look. This is a hinge here. That's a hinge. See that? That's a hinge. So there would be a reaction at the hinge. I want to know, maybe somebody can tell me, which way is the reaction? There's a reaction force at the hinge. Does anybody have any ideas which way the reaction force is? Is it right? Is it left? Is it up? Or is it down? You think up? Good, yeah. What else? Downwards, you think? Upwards? You think left? And nobody wants to say right? There's actually two reaction forces, because if you think about it, if I put the sign at the wall, if there's no hinge, what will happen to the sign? It won't fall. So the hinge must be providing upward force reaction. Also, if I put the hinge into the sign into the wall, it stops. It stops because the wall is pushing outwards, like this. So there's actually two reaction forces. So there's one force going this way, and there's one force going this way. And normally, what we do, actually let me put them in different colours. One force going this way, and one force going this way. And normally what we do is we put the two forces together to make one reaction force, like that. Okay, what was question number one? What did I ask for? The tension, is it? Yeah. Can anybody tell me what this angle is? 45. So then this force here and this force here, these are both, well, okay, I won't put that in. This one is T cos 45, and then this one here is T sin 45. Yep. Okay, now I'm going to use this as my turning point. So if you look here, this force, is that clockwise or anti-clockwise? This one is anti-clockwise. This one here?
Clockwise.
Nope.
No, anti-clockwise.
Nope. It's neither. Why not?
It's not wrong.
Why not?
Does not have an opposite perpendicular.
Because this force goes through the turning point. This, we ignore it. And then this one here, clockwise or anti-clockwise? This one here, the white. It is clockwise. So the turning force anti-clockwise, that's equal to 0.4 times t sine 45. And the turning force clockwise, that's equal to, what's the distance? Who can tell me? For this one. It's not 0.4. It's 0.2. 2g. So that means 0.4 t sine 45 equals 0.2 times 2g. So I get T is 13.9 newtons. Okay? What's the second question? Let me give you a moment to write it down. So, this is the next question. Got it? Yep. So let's have a look. So can I just remind you that when something is in equilibrium, when it's balanced, you have up equals down, left equals right, and then clockwise equals anti-clockwise. So if I go back here to my picture, this is the force I want. Let me call it here x. So I can actually see what x is. What should x equal? X should be the same as what? Who can see it? T cos 45. Because the right should equal the left. So for number 2 here, x should equal T cos 45 which will equal 9.81 newtons. And question number 3, I asked for the vertical. So who can tell me what the y should equal? Well, it's not quite as clear, but you have y plus what? Y plus what? T sine 45 should equal, what should it equal? 2g. It should equal 2g. So here, this one is the left should equal the right, this one here is the up should equal the down, and this one here is the anti-clockwise should equal the clockwise. So this means I get y equals
2g minus?
Yeah, 2g minus t sine 45, which as long as I type this in right, you get y is 9.79 newtons. So this is just saying the up is equal to the down. Yep. Is that okay? Yeah. The last part here is I want to know the magnitude and direction of the reaction force. So this is part 4. What is the magnitude and direction of the reaction force? Question? Okay, go ahead. You can do it. You need more vertical force. Go on, you can do it. Keep going. That's it. Oh, so strong. Okay, can I go back? So here I want the magnitude and direction of the reaction. Can I go back? Yeah. So look, you already have the X and the Y. Let me draw what we have. So here's the hinge. And you know there is a force here of 9.81. And you know there's a force here of 9.79. So what I want is the magnitude and the direction. So how can I get the magnitude?
Pythagoras.
Very good, Pythagoras. 9.79 squared plus 9.81 squared. So that is 13.9 newtons. And who remembers how to get the direction? Tan inverse. Tan inverse.
9.81.
Wrong way. You got a 50-50 chance. 9.79 over 9.81. So that is 44.9 degrees. This is part 4.
To ground us, then it would be on 45.
Yep. In fact, I have a feeling that's probably exactly 45. Anyways, you have this? So I have seen this question in the exam, but what's important is in the exam, they won't break the question down into parts like this, okay? The question would just say, what is the magnitude and direction of the reaction force? So what I wanted to make clear in this example is, these are like the steps to get to this answer. So in the exam, they won't give you these, because this will be a section A question. So section A question doesn't have parts, it just has usually one question per one question. So in the exam it would say blah 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 blah, and then what is the magnitude and direction of the reaction force? So I just want you to know that in the exam they won't give you the steps always. You have to know the steps yourself. So here we look at turning force, horizontal, vertical, answer. Turning force, horizontal, vertical, answer. And this is actually quite normal. Okay. Right, so we have some questions here for you to try. Let's see. Yeah, I think you'll be okay with these. So I'll let you try these for about 5 or 10 minutes. And then you can take a short break, and then we'll start the next topic. Okay? So see how many of these you can do now.